Okay, here we go with question 10, all about microwaves. As ever, please take some time to try the question, and then when you're ready to see an explanation, carry on watching the rest of this video. Okay, so we're looking here at microwaves specifically, and we're firstly defining them as transverse electromagnetic waves. Okay, now often when you are given the word transverse, you should expect to have to define that. Look here, we've got it here. So first we're going to state a use of microwaves. And I've given a couple, or three to be precise. We've got microwave ovens, satellite TV, and then mobile phones. That's three examples. It's usually good to have a few different applications up your sleeve for each of the different types of radiation. The most obvious one to people here is microwave ovens. However, you might have a question which says, other than cooking food, for example, suggest a use of microwave ovens, and that way you need to have a few more. Satellite TV is always a good one, mobile phones as well. Okay, I think Bluetooth was another one which has come up recently, which is kind of a new addition to the syllabus because of the use of Bluetooth so much in society. So be aware that you need to probably have a few of those different applications ready to go. As I've said, we're going to describe a transverse wave, and this time I think I've done a better job than when I did longitudinal in a previous video. Okay, a transverse wave is a wave or in which the vibrations, you notice I've used that word vibration, are perpendicular to the direction of energy transfer. Okay, so we're looking here at vibrations and that idea of perpendicular. That's an important one for our definition there. Okay, we've got figure 10. We've got a ray of visible light traveling in air, and it's incident on a boundary between air and glass. We know the refractive index of the glass. First thing we're asked is to calculate the angle of refraction. Now, I've done over here a little 3 exclamation marks. Why? Because this is a 3-mark question. 3-mark questions involve doing something else, just involve an extra bit of difficulty. So let's see why that is 3 marks and not 2, because usually that's what a simple calculation question would be. Well, we're going to use our equation here, n equals sine I over sine r. Yeah, we know, let's just get this right, we know n, and we know the incident angle sine I, and so therefore we know I, we know sine I. So we're going to rearrange first. We're going to use the fact that sine I is on the top. Okay, and so therefore if we want to get sine r, we're going to swap the n and the sine r. Sine r is equal to sine I over n. You're going to do sine 48 over 1.25, sorry, my 2 looks like a 1 here, and you get 0.594. Now, this is where the 3rd mark comes in. You're going to get a mark for doing this, you're going to get a mark for doing all this, and then you're going to get a mark for remembering, whoops, I've used I here, should be r equal to sine to the minus 1 of this. So we're using the inverse sine, arc sine. Okay, that's where the extra mark comes from. Remember, if you've got 3 marks, you are usually having to do something extra, something harder, right? And finding the angle from a sine of an angle is deemed to be hard. Now, some of you might be sitting there going, it's pretty easy. That's nice. It's an extra way of getting some marks, which is fantastic. Okay, we then come on to drawing. All right, now again, I've noticed that a lot of students will find this kind of question a bit tricky because all you have to do is draw, but there's no space underneath here, okay, to do any of the extra bits. All right, so let's go back up to our drawing. We're going to draw the refractive ray. What we're first expecting is a straight line, which is connected here. Okay, so at this point where we join, we are going to draw a connected line. Now, to get the 2nd mark here, you're going to have to make it bend towards the normal. Why are we bending towards the normal? Well, that's because this is refraction due to the change in speed, and in this case, it is slowing down. By slowing down, we are going to bend towards the normal, and therefore, we're going to have this angle getting smaller. So anytime you're going into an area of higher refractive index, remember air has a refractive index of 1, the glass is 1.25, you're going to slow down and bend towards the normal.